Hello. Okay, this project is about like this. In this box there is an accelerometer, the analog device 355. It's very high precision accelerometer, and I use it to measure the inclination, and is according to document got precision of you can reach like 0.005 degree, like noise, so like you can read a data of 0.005 with a very low noise and still get like something accurate. So in this device, what I'm doing, I'm trying to get even better precision. Cause why? I put here a graph in the back. Okay, so the sensor, of course, in theoretically should give like a linear graph and of his reading of inclination versus the reading that he gives. But of course, in practice, the graph is not linear. We got more precision near the center. This is like the 0 degrees, and we got like this is the G here, but the G, of course, is translated into degrees with trigonometry. So this is the 0 point. We got a lot of resolution here, and as we go, we starting to get a bit of error. And in the end, of course, close to 90, it's not that good at all. So this is like for if you tilt the sensor to one side, and this is if you tilt it to the other sides. Of course, this sensor have got 3 axes, X, Y, and Z, but here I don't use the Z, I use only the X and the Y. And on this device I'm trying to calibrate just one of the axes. So here I'm trying to calibrate the X-axis, and how I'm doing it, it's in kind of a new approach that I'm trying to move the sensor with stepper motors, change the degree. Stepper motors are very precise, so I can move it in a very small degree, and I know what is the degree that I'm moving the sensor, and then I'm just recording the reading of the sensor at a position that I moved it to. So if I will do it I will like, okay, we got flat, and we increase in like some degree, and we record the value. Another degree, record. Finally, we have a lookup table. So if you've got a lookup table, for us there is more data to store in memory, but we got better precision than using the graph that we saw previously. Because this graph, usually what you do is you've got a linear equation, you put the data in the equation, and you get the degree that you are in, but it's not precise. So what I'm doing here, it's trying to gain more precision along all the way of the sensors. Usually you will get very good result, close to 0, but as you proceed you will start to lose it. So this was what I'm doing in a device. First of all, I'm balancing. There's a stepper motor on the other side of this box right here. We see the cable. It will balance just the Y, because I want the Y to be in 0. And then I will go and balance the X-axis with this. I will explain in a second. There's a stepper motor here with it will balance the second axis, and then I will move it and start to record. So basically this is just a rotary table that I had. It's used for milling, and I use it for this because it's kind of precise, and I already have it, and I don't have to remake another mechanical device. So I just like printed some adapters. Here you got the stepper motors that will move the rotary table. The rotary table got a gear. It's got a gear ratio. It's got a worm gear, and it's pretty precise. So let's start the movie, and we will see that. Okay, here resetting the microcontroller. The microcontroller will move the Y. It will move it kind of close to the center, and then when it's close to the center, it will do just a little small increment until it will get close enough to 0, enough as I configure it to. So here we see like the first movement, and then the tiny movement until we reach around very close to 0. Of course we can't get into 0, but I defined it like a certain range that for me it's good. Another thing, there's no cooling right now, but generally on the top of this there's a tape here. The sensor is just under this tape. I taped it because the ambient air in the room is good, and I don't need to cool or warm the sensor. The sensor functions very well under 25 degrees Celsius. So what I did is I installed the tech or thermoelectric cooler on top of it with a heatsink, no fan, of course, no rotation will be very bad here, and I did like kind of a closed loop circuit that measured the sensor got inside the temperature, I'm reading the temperature and just driving the tech. I can drive it both way, like to cool it and heat it. I'm using an H bridge that used for motors to turn the current to this way or the other. So generally it's kind of complicated to connect here, and my ambient temperature in the room while doing it was good. Also, this is this is what I do. Also, this is an old project that I disassembled, so I'm taking a video that I had and I'm explaining on it. So okay, we'll continue here. We already saw this. Okay, so this is taking the Y to 0. Now it's at 0. It started to take the axis to the 0. So we're taking the sensor, we are driving it to the 0 position. You can see the movement, and again we are doing like kind of a very big movement, not so fast. We're taking it closer to 0, and then we will do very small movement until we reach to 0. And from when we reach to 0, we start to increase here. This is the slow, very slow, and change of the readings. It is a bit fast, so it's going to take a bit of time on this one that I recorded. You can see here the movement. It's very small. And once it's reached 0, it then starts to add a degree, add record, and every time he's adding, of course he's adding to the x-axis, but after moving it, it's also checking that the y-axis is still in 0. And if it's not in 0, it will fix. Why? Because I want the y to be in 0 while I'm doing this data recording on the x-axis. I will try to run it a bit forward because it's gonna take time. This recording was a bit slow, and even now it's going even to the 0 in a more precise way until you will reach a desired good value. Axis is at 0, and now it's starting to step, and this value are recorded. It's gonna record it, and then once we finish, we will have a table of all the record of the sensor data, and we know that from one to the other we got like a certain degree delta difference. Okay, now this is the recording. It's putting it in an array, and he's recording the degree, the data. Here we can see, degree movement, recording, movement, recording. This is the 0, not this one. This is like the 0. So from here it's starting to move. This is something that I added. This is the device. And here on the text file, this is the text file that he records the data. Is every time he's adding here the value. And it's it. So that's it. In the end, we will have a lookup table, and actually I can say that this thing, I have some very precise gauge block that measure degree. After recording, I upload the data to the sensor, I start to use it, and the result wasn't like in the very precise, in the precision that I wanted. It's took me a while to see why, and I learned something about stepper motors, that stepper motor are very precise. If you move from, if you take a stepper motor and you do like a full 360 degree, you will get to the same position in very like 0.005 degree, something actually like this, even better, because stepper motor in this way are very precise. But if you are making with stepper motor only one step, this one step won't be the same as the one step after it. Why? Because of the tolerances. The stepper motor tolerances, it's not the best. So if you move it let's say we move it from one place to the other and back and forward and back and forward, it will go to the same position with very precise with very good, very good precision. But if we increment one and one and one and one, the delta between each of them, it's not the same because of the tolerances. So like the stepper motor knows how to get to when it is going to the 0 or the, let's say 45 degrees or 90 degrees. If you do a full rotation and go again to 0, 45 or 90, it will go to a very same spot, because the same spot is he knows how to get to it, because it's very precise. But because the difference of the tolerances between one step to the other, the degree is not the same. It's not constant. It's not like I don't know 0.005 degrees. One of them will be 0.008 and one will be 0.002 or something like this. So this is why actually this was very nice, but in the end it was nice, but not the precision that I wanted it to be.